Hello, everybody, and welcome to this presentation on algorithms, part 2. We'll be focusing on implementation for years 3 and 4, and also years 5 and 6. This is the 4th session in the series. If you did want to see the other session prior to these, please have a look in your own time. The algorithms part 1 links really nicely and closely with algorithms part 2, so I would recommend having a look at that one. Just having a look at the timing of today's webinar, there'll be a few introductions from Nathan and myself, a session overview. We'll be looking at how we go from an algorithm to a visual program, what's new in the Australian curriculum, version 9, some activities to explore the concepts, and how we can go about assessing coding. Just like to introduce myself. So I'm Chad Ivich. I spent 5.5 years as a digital technology specialist in both primary and high school, and I thoroughly enjoyed it.
My name's Nathan Allison. I'm a lead educator at Grok. I had about 11 years teaching digital technologies in secondary schools in Victoria. And more recently, I was a professional learning coordinator for our subject association in Victoria, which is DLTV. So our goals for this session are to introduce this concept of what is implementation, as opposed to just what we talked about in the previous session on algorithms. What does implementation actually mean? And as we said, we'll be highlighting some differences between version 8.4 and version 9 of the Australian curriculum. We will demonstrate some activities and tools for doing what we call visual programming, and we'll discuss what that means as well. And we'll also talk a little bit about pedagogy and the fact that we do have some pedagogical tools now for teaching coding. So we'll talk a bit about that as well. We showed this sequence in the previous webinar, and the Australian curriculum version 9 and 8.4 for that matter has this big idea of creating digital solutions. And we go from defining the problem that we're looking to solve or the opportunity we're addressing, working out what we want to do. Then we do some design work, designing algorithms in this case. Then we implement, and implementing basically means developing it, making the code, actually writing programs that can run on a computer or on a digital device. And then the final stage is to evaluate. And this looks like a flow just from left to right, but of course, design methodologies often have, you're going back to previous steps again and iterating. Now, who remembers this from the previous webinar? This is a recipe. If you're not sure what it's for, you might want to go back to that webinar and check. But of course, this was a recipe for a pancake mix. And we made this flowchart we didn't make it, we discussed this flowchart. Basically, it takes you through the steps that you see in the regular sort of recipe on the left-hand side, but it's now portrayed visually as a flowchart or an algorithm that a computer or a robot could follow to make the pancake mix. And this is really what implementation is. Implementation is translating an algorithm. You're taking it from the sort of more human-friendly format that it is initially, whether that's a flowchart or something in plain English, like what you see on the left there, and you're turning it into code. And in the primary years, you're turning it into a visual programming environment code. So visual code looks very similar. There's different types of it, but the one you see on the right there, Blockly, is a good example. The colored blocks are very helpful for students to kind of get an idea of what they do, and then they kind of click together like Lego bricks on the screen in order to make the programs. Now, you might be wondering, what about things like Python and JavaScript and all those other languages? Those are specified in the curriculum from years 7, 8, and 9, 10 up, but they're not specified necessarily in the primary years. It doesn't mean students may want to extend themselves and do that, but in the primary years, we mainly discuss visual coding like this. This slide we put in as well in the previous presentation. Just a reminder that the content descriptions in the curriculum are there to tell you what to teach. They're explicit statements about what needs to be taught. And there are elaborations to help you know, get some ideas around how you will teach it. And then how will you know that the students have learned it? That's the achievement standard that you refer to for that. So let's have a look at the differences between 8.4 and 9 for years 3 to 4. One of the things you'll see is that specific concepts like branching and iteration are now put in with algorithms as opposed to with implementation. The content description for implementation just refers to those collectively as control structures. So when you look at the version 8.4 content description on the left there, you can see that it does mention in blue branching and user input is there. On the right-hand side, we don't use the word branching. We just say control structures, and it's just input. Input may not always come from the user. It may come from sensors, for example. What's the temperature or what's the light level and things like that. So that's one of the changes that's occurred. And as we looked at in the algorithms part 1 session, there is another content descriptor now that collects the stuff about branching and iteration. So what are control structures? These are the decision-making building blocks, according to the glossary there, of an algorithm that determine or control the flow of which parts of the program, which statements are executed, which parts get run first. So the control structures are sequence, branching, and iteration. So one way of thinking about it is control structures are like the implemented version of those branching and iteration and sequencing that we discussed when we looked at algorithms. And Chad.
Yeah, so Nathan did just mention visual programs. So we'll just have a quick look at a definition of that, also from the Australian curriculum. So they are programming language where the program is mainly represented and manipulated graphically rather than as text. Statements and control structures within graphic blocks can be composed to form programs. So you can see an example there. There's a lot of sequence happening, and then there's a decision to be made about the bunny ears. The visual programs are fantastic for years 3 to 6 because in that visual programming environment, students are just are dragging and dropping blocks, and they can get building programs and thinking about logic without actually having to learn all the syntax of text-based programming languages like Python and JavaScript. So it's just fantastic. They can click and drag and drop and run and test and yeah, it's really awesome. Just looking at the achievement standard, what's been highlighted there. So in algorithms part 1, we looked at they follow and describe simple algorithms involving branching and iteration at the year 3-4 level. And today we're focusing on implementing them as visual programs. Okay, so a way to look at some of the control structures and that Nathan was just talking about. So sequence, branching and iteration and input. One way to do that is to do a little demonstration of a Grok course that has all those control structures within it. This one's suited to years 3 and 4. It is actually the second one in the series, so it's called More Monster Maker. So we decided to focus in on this one as the first one is just learning about creating monsters as opposed to those control structures that I just mentioned. Okay, so here we are on the Grok Academy platform. About halfway down on the right, there's a search feature. So I'm going to type in More Monster Maker, hit enter, and here's the course that I wanted to show you. It does have 5 different modules. Blocks inside blocks, ask questions, make decisions, decisions with options, asking more questions, and more than one right way. So I wanted to zero in and show you some of the slides and a diamond question as well. So we'll just start in this one here. So here's an example in module 2. The circles on the left are slides with content, and you can also run the example programs as well. And the diamonds are little challenges, little coding challenges where students can practice some implementation. So this one is just saying, do you want to draw a monster? Let's write a program that lets your friend decide. So just linking what happened in algorithms part 1, where the algorithms were either in plain English or flowchart. So we've got a flowchart here, draw the monster body, and then we've got a decision to make. Do you want a hat? So if the answer is yes, to draw a hat. If not, if the answer is no, you draw the eyes. So this is the if block. And then we can use it to help us make a decision, and that'll be in a part of the program that we're building. And the ask block is outputs a message to the user to prompt them, and then we can input with either yes or no. So I can't run this program yet. I think the next time I'm actually able to run some code. Here we go. So that little triangle there allows me to run the code that's in this little light blue window. So, and the program is, if we answer yes, then we're going to draw a beanie. So initially there'll be a small head, and then we're prompted for user input, do you want to wear a hat? And if we do yes, we'll draw a beanie hat. So I'll just run that one. So here's the input prompt. Do you want a hat? And I say yes. And so I get a hat, which is good. I'll just run it again. And there's a drop down to say no. And this time I'm not going to get a hat. All right, so this time we've got a bit of sequence happening. Draw a small head body with that color, 3 round eyes, a bump nose and upside down mouth. But then there's a decision in this program. And so we're just combining some sequence with input from the user and a decision. So that's quite a few of those control structures that were mentioned in the achievement standard. So I'll run this program. So going through all the sequence steps, prompted for user input, do you want a hat? Yes, and I get the beanie. If I run it again and say no, same thing's going to happen, minus the beanie hat. Okay, and moving on. All right, so I'll just move this window down. So in Grok, there is diamond, they're like coding challenges. So I'm asked to, this part of the program's been started for me, the sequence for drawing the monster. And then I need to use an if block and type in or prompt the user, are you going out to play? And then if the answer is yes, I need to draw a sun hat. So if I go, first of all, if I get a decision block, and then I type in, so in this ask block, what I type in here, the string is what prompts the user. So going out to play. And then if the answer is yes, I'm asked to draw a sun hat. So a sun hat. So at the moment, I've got a beanie hat. So if I just drop down, I've got a sun hat there. So I'll run this program. And I've got my monster. Am I going out to play? I think it's nice and sunny. So yes, I need a hat. And there we go. Yeah, so, and I'll just mark it over here. So the marker is on the top right-hand corner, and then I'll see if I've got everything correct. Yep. So I passed all the tests. Is my program the right order? That's important. Does your monster look right? If we answer yes, does the monster look right? If we answer no, we didn't test that, but there wouldn't have been a hat if we did no. The marker tested that for us, actually. So that's how that one works. Okay, so here we are back at the slides, and I just wanted to connect with the content description. And we saw that we had a flow chart, and we translated that flow chart into a visual program when creating the monsters. And some of the control structures that we just looked at were sequence and branching as well. So we did show this free Grok slide last week, but we did just want to remind you that the course we just showed you is one of the free ones on the Grok platform. And if you want to teach visual programs to your students, there's many, many other courses. So yeah, really exciting that Grok Academy went into partnership with WiseTech Global last year. They've struck up a partnership for 5 years, which means that students and teachers and parents and even adults in Australia can access and learn digital technology skills free on Grok Academy.
Yeah. Just returning then to our differences between version 8.4 and version 9 of the Australian curriculum, and now looking at years 5 and 6, we can see that the same thing has happened with years 5 and 6 in that there's a separation now where the implementation, the content description that's about implementation, which is on the right there, no longer mentions branching and iteration explicitly. It just talks about control structures. So it's implement algorithms as visual programs involving control structures, variables, and input. And variables are the new thing at years 5 and 6, and we'll talk about those in just a moment. We look at the achievement standard for years 5 and 6. Once again, variables are mentioned there. So in the sentence that's got the blue part there, students design algorithms involving complex branching and iteration. And here we go. And they implement them as visual programs, including variables. So what are variables? So according to the glossary, variables are data values that can change depending on the conditions during the running of a program. Sometimes people like to talk about them as if they're like a bucket that can hold a value or can hold a number or a text or a word or something like that. So some examples are, we might have a variable called name, and that stores a user's name so that the program can respond with their name later. Or there might be a variable called moisture, and that variable basically stores the current soil moisture level. And then you can use that number later to decide whether a robot might add water to the farm. So in this little visual example on the right, we have a variable called library day, and the library day is being set to Friday. And then so it then prints out, don't forget library day is, and it reuses that variable called library day. So what you'll see on the screen, it'll say, don't forget library day is Friday. On Friday, you need to remember your library bag. Why would you do this? Well, this means that you could change Friday to something else in that first block there. You could say set library day to Wednesday, and the next two lines can stay the same. Don't forget library day is Wednesday. On Wednesday, you need to remember your library bag. So variables are something you can store with text or with numbers, later on with other things too, and it allows you to reuse those values later by referring to that variable. And Chad's going to take us to another demo.
Excellent. Thanks, Nathan. A nice way to explore some of the content descriptions that Nathan was just reading to us before is a course like this on the Grok platform called DT Challenge Blockly Chatbot. You may notice just underneath there, it's been produced by the Australian Computing Academy, and you may also recognise the pixelated logo of the map of Australia. So the Australian Computing Academy have developed this course, but they have become a part of the Grok Academy. So all their courses are on the Grok Academy website. So this course is suited for 5 and 6. It's a really cool one because it's when students are writing the programs, the user gets a sense that they're interacting with a program that has some sort of intelligence, and it changes its behavior based on the user input. So it starts to get exciting from a writing programs perspective. So what we're going to do is just have a look at a couple of slides that have relevant content and concepts, look at some diamond problems, and have a look at the marker as well, because that's really useful for giving feedback to direct students thinking if they're not quite on the right track. Okay, so here we are back on the Grok Academy platform, and we're just looking at the DT Challenge Blockly chatbot course. So I'm just going to go into that. And I thought I'd like to show you a question that had loops, a diamond challenge that has loops. So I'm just going to go into this one here. There are 10 modules in this course, but we're just going to zero in on repeating things on the loop. This is a nice question. It's about an alarm that goes off, and you can try and hit snooze, but it's a persistent alarm. It's not going to let you hit snooze, and it'll keep annoying you with meep, meep, meep until you actually type in "I am up" with an exclamation mark. I have started the program, so and this is the example output here on the left as well. So you can see meep, 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 are you up? If you type in no, you get annoyed again. Meep, 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 are you up? If you type in I'm sleepy, until right down the bottom you type in I am up, and then it finally lets up and says took you long enough. So I'm outputting meep, meep, meep. I did that before. So what I'm going to do next is I'm just going to create a variable. Yeah, and I'm going to call that answer. And then I'm going to get a loop. And I'm just going to change that in the drop-down menu to answer. And in this ask block, I want it to output, are you up? Question mark. And then I just go into logic block and grab my answer variable. And I'm going to say grab another string. And I'm just going to type in I am up.
So the color coding we mentioned earlier, you can see Chad's used the orange block has to do with loops. So whenever they see orange blocks, they know that that's going to be a control structure that's to do with loops. The green blocks all tend to do with input and output. So, the green blocks all have to do with strings. So it's asking you, are you up? And then the variable blocks are all gray. So whenever you're dealing with variables, they're gray. So the logic of this program, if we just, before you run it, Chad, we'll just step through. So you can see there, it prints meep, meep, meep. Then there's a repeat block, which is a loop. It's basically saying it sets the variable answer to whatever they put in, because it asks them, are you up? The user puts in something. Maybe they put in no or yes or something like that. And then it will keep repeating while the answer is not I am up. So unless the user types in I am up, it's going to keep repeating. It's going to just say meep, meep, meep again, and it'll take us back to the start of the orange block again and ask them, are you up? And then finally, if the user does put I am up, that means that condition there will fail and it will jump out of the loop and down to the took you long enough. So let's have a go and see if it works.
Thanks for explaining that, Nathan. I'm deliberately, the Grok marker looks for specific characters in the strings as well. So I'm going to get it to output took you long enough without the exclamation mark, just to show you what the, even though the program's correct, just to show you what the marker does.
It's pretty pedantic.
Yeah, hopefully we get everything correct. And oh, actually, well, we'll go with this. I'll say no. Are you up? Not yet. And it'll keep annoying me, but if I type in I am up, we get took you long enough, but the output is not exactly like the output in the example. There's no exclamation mark. So if I mark it, we should get everything right, but the marker will complain about the missing punctuation mark. In theory, I reckon it's pretty good. Okay, yeah. Testing first example, your submission did not produce the correct output, your program output. Yep. And I think it's just notice the missing exclamation mark. So I'll pop that in there. Cool.
Pressing mark again now. And this time it marks it and it's all correct.
Yeah, so the mark was just saying the output isn't the same as what I was expecting in the example. Okay, now that we've had a little bit of a look at the Blockly chatbot course, we're going to move on to the next slide and have a look at an activity that could be based on that course. So obviously, if you're working with students, you would want to go through slides and diamond challenges that are covering the the three control structures, sequence, branching and iteration, and also input and variables. So once students had had a go at slides, running code, building their own visual program, answering challenges, you could give them an activity based on some of the concepts that they've learnt in the course. So what you could do is ask them to develop a chatbot that asks the user to guess their favorite animal. So initially you could ask students to act out the algorithm using their voices. So one student does a robot voice asking the user to guess their favorite animal. So, and the other one's just guessing until the answer is correct. So once they've had a little bit of a game like that, students can use a Word document as a scaffold to help them design their own algorithm in plain English. And then they could have a go in the Blockly chatbot playground, which we will show you. Yeah, and they go through the process of implementing or translating the plain English into an algorithm, into an actual program that runs. So this is an example or a sample of students' work. So we've got at the top, you're just asking them to state the purpose of your chatbot program, and they can write in what they wanted there. We have a bit of a there's a bit of a tick box there, so that they're just checking off that they've got all those important concepts that you want to see in the algorithm, like as you can see. And then down the bottom is the plain English for all the steps that they want the program to go through. So start, the chatbot says, try and guess my favorite animal, create a variable called guess and ask the person to type in their answer, have a loop going while the guess is not lion. And the student's written there, if guess is lion, chatbot says you guessed it, else chatbot says wrong, try again, and then ask the person to type in a guess again. Then the student's written end the loop, and then the chatbot says, well done, you guessed my favorite animal, and the program ends there. So if we have a look at the, we'll go off and have a look at the chatbot playground now. Okay, so just coming back to the course, this is the problem that we did before, snooze no more. For the activity that was mentioned not that long ago, the students can actually go into the playground, the chatbot playground. And that's a nice place where they have free reign with all the blocks and an opportunity to take that algorithm in plain English and try and implement it, translate it into a visual program that runs. So students would need, for the chatbot guess the favorite animal, they would need to access a string. They would need a print block, or that's a nice one, the print command with a string in there. They would need to ask for text with a prompt. Need to create a variable. We would need decision block as well. And we would need, students would need a repeat while do block as well, and a comparison operator as well. So there. I have had the opportunity to directly translate the student's algorithm that we saw in the handwriting into code. So I'll just show you what that looks like. So
this is one we made earlier.
yeah, yeah, just to save you some time. Okay, so that's a direct translation of the student's handwriting. So we've got print, hi, I'm a chatbot, can you guess my favorite animal? We've created a variable called guess, and we're prompting the user to type in their guess in lowercase letters, and whatever they type in is stored in that variable guess. Then we've got a repeat loop while the guess is not lion. And then the student had a if, do, else inside the repeat while do loop. And they have if the guess is equal to lion, print nice one, you guessed my favorite animal. And if the guess is wrong, they're printing out good try, have another go, and they're prompting the user to type in and guess again. If the user types in lion, then we pop out of the loop and the program outputs, congratulations, you guessed my favorite animal. So I'll just run that program. So I'll type in dog, good try, have another go, zebra. Good try, have another go. So I'll type in the correct answer. And we get, congratulations, you guessed my favorite animal, it's a lion, roar. So you'll notice though, the student had a if guess equals lion, print nice one, you guessed my favorite animal. And kind of these two output messages are pretty similar either, but once the user down here typed in lion, we popped out of the loop and never actually got back to if in here, if guess is lion, print that out. So to make the program a bit more efficient, and the repeat while do is dealing with the guesses correct anyway. I'll just show you, I'll move that out of the way, and I'll turn like an improvement on this program. So we'll just get rid of that one. So the difference here being that if the guess is not lion, then we want to print out try again and then prompt the user to type in their next guess. And then we've got if guess equals cat, print think bigger. So we're giving if they're close, we're giving them the hint to help them get the right answer. So if I run that one, do dog again. So you get good try, have another go. I'll type in cat, and the chatbot responds with think bigger. So hopefully that's a clue for the user. And then finally we type in lion. and we got the correct answer, and the output's raw. Yeah, so that's just an example of how you can use the Grok platform to do an activity that you've developed yourself in the playground, and hit on all those really important concepts that you're trying to teach the students in years 5 and 6. Okay, we might just go back to the slides now. Oh, cool. Thank you. So you can see that same program there. And students can understand demonstrate their understanding of the program by adding comments. So if you go on any of the blocks, you can right click and you can create a comment. And this is really good for like formative assessment purposes. So you based on what the students are writing, you can monitor their progress, and it can inform your teaching practice. So if you were to see comments like this, you'd be pretty confident that the student has understood the program. So they've got on the set guess block they've written variable to store guess input from the user. So that's spot on. Loop to keep asking for animal if guess is incorrect. That's what you'd want to see there. If guess is cat, provide a hint. And the last one is broke out of the loop as the guess was correct.
So the Grok platform is one of a number of different ways to do visual code. Another one you may have heard of is the MakeCode platform, which is used for the microbit. You can do Minecraft related coding, and also there's these other little devices that are kind of like tiny Game Boys, and you can do this thing called MakeCode Arcade. So this is another visual platform. Once you get on there, you see the code blocks and you can start to build code, and it's very similar looking to the Blockly, but just a slightly different environment. Another very popular one is code.org. As with Grok, you can assign courses to students and track progress. And they have special one-off activities as well. And they also have interspersed with unplugged activities and things. Code.org is American-based. Another option is to do a bit of physical computing. I mentioned the microbit, which is like a little microcontroller device, but there's lots of others. There's Lego Robotics, has its own visual coding, and Sphero, and there's a number of other platforms for doing robots and other what we call physical computing, so that you can have things happen in the real world because of your code, which is a really tangible, really great way for students to be engaged with coding. And then another very popular one is Scratch, and I'll be showing a little demonstration program in a moment that was made in Scratch. You've probably heard of Scratch. There's Scratch Junior for the lower primary, and then regular Scratch is very well suited to upper primary. The last sort of demonstration activity we've got for this session is a program suited to years 5 and 6, and this is the program we developed, the algorithm we developed in the last session, which is the getting the computer to try and guess a number between 1 and 100. And this was our flowchart that we came up with. And just as a reminder, we start the program. The program says, think of a number. It's telling the user to think of a number, and then it tries to maintain these upper and lower boundaries so that it can keep guessing and getting closer to the answer. And it has to keep asking the user, is this correct? And the user has to respond, no, you need to go lower, or you need to go higher. And then we get to the finish once the user tells the program that it's correct. Now, on this slide, you can see the completed Scratch program. And it looks like a lot when you first see it. You can see I've got little comments at the side there of what each part does. There's a little bit of code here. If I put the highlighter on, you can see in this part of the code, there's a fairly complicated bit of code here to do the maths that's needed to get the halfway point between the lower and the upper, as we talked about. And then there's a one big forever loop that keeps going while the computer is doing its next guess and asking if it's correct. And then we have all these if blocks here, our control structures, our branching. All these if blocks are to ask, am I correct? And depending on what the user does, it checks those to see if it's correct, too high or too low, and then changes the values of upper or lower. And then if they did get it, we've got a little cheat here. We just stop the whole script without doing anything else, and that will actually end the program. So this is quite big. This is pretty big as it is. This is a lot of code to take in. And there's a link there if you do want to just check the Scratch program yourself and have a go at it. But what I wanted to talk about next is how we actually learn a little bit of coding pedagogy here, because we wouldn't just give this to students and get them to copy it out. There's very limited amount of learning that can happen if a student just copies out a program. It's not that it's completely worthless, but it's not necessarily the best pedagogy for coding. So one of the ones that's used these days quite a lot is called PRIM: predict, run, investigate, modify, and make. It is a research-informed pedagogy, and it basically helps students to have a structure for how students can move from just being able to use someone else's program to actually being able to write their own programs. And we'll talk about what each of these phases is, but what's really happening in PRIM is that students begin with code that's not theirs on the left-hand side there, code that's not mine. That's when they're doing the predicting and running and investigating. And then they modify that code for a different purpose. So now the code is partly theirs. And then they also start to make their own code. And then the code then is all theirs. So let's have a look at what these phases actually would be like for our example. In the predict phase, what you're doing is looking at a short program and trying to decide what it will do. So when we look at this little bit of Scratch code, we're asking the students to basically, what would this part of the code do? You notice it's not the whole program. I've just taken a little portion of the program rather than the whole thing. There's no loop anymore. There's just this one branch here. But basically it says, think of the number, don't tell me. It sets its first guess to a random number between 1 and 100. It asks if is it that number? And then if the user says correct, it says, I got it. Nothing else actually happens. So if the user doesn't say correct, it doesn't try again. That's just the end of the program. Now, getting students to try and predict what code will do before they run it is one of the important steps of PRIM. If we look at the run, in the run phase, basically the students get part of the code and they have a go at running it and seeing what happens. The program is written by the teacher, or it's found from somewhere there's a made program. So the students are really just seeing what the program does. And once again, I've cut back a little from the whole program. I've added a loop in now. But if you see how this program works, it's just continuing to guess between 1 and 100. It's not adjusting its guess very cleverly. It's just guessing from 1 to 100. So it's basically got a 1 in 100 chance of getting it right every time. And the user is either going to put correct or not. If they do put correct, it stops everything so the loop won't continue. So that's what would happen if we were to run that in Scratch. In the investigate phase, this is when students do varied exercises on code to try different things out. So for example, the teacher may provide the students with some code that has errors in it, deliberate errors, and the students have to find out where those errors are. So they're debugging. That's called debugging the program. Students may be given pieces of the program, but not in the right order. This is called a Parsons problem. And they have to put those pieces of the program into the correct order in order for it to work properly. And then Chad gave a good demonstration of annotation before, but that's where students write comments or otherwise annotate a program to explain what parts of it does. So that's the investigate phase. And then an example of modify would be students changing the existing code to improve or alter the behavior. So perhaps rather than a number guessing game from 1 to 100, an initial easy modification would be, I don't want it to be 1 to 100 anymore. I want it to be 1 to 50, or maybe 1 to 200. That's a sort of more straightforward modification that the students could make to the code. Or it could be something a bit more advanced, like maybe the computer only gets to have 5 goes and then it fails. And then it says, sorry, I didn't get it, or something like that. They have to do some kind of modifications. That's a bit more of a complicated modification to make to the code to do that. And then lastly, students try and create their own programs. And you might want to go with something that uses many of the same structures they've been learning in the other parts of the PRIM process. but students then have a go at making their own program. So taking you through that little prim model there, just with that example that we did, I hope that's helpful to get a better of a look at one of the pedagogies that's used when we're teaching coding.
Okay, thanks, Nathan. So moving on to assessment and thinking about how do you assess coding, it is quite a challenging aspect when teaching digital technologies. So just a couple of questions to get you thinking for a moment. So is it enough to just complete everything? So you could assign students courses on Grok or code.org, and if they finish everything, does that equal an A? And also another question is, what is good code versus code that's not so great? Yeah, and how do you know the difference? Just talking about assessment, just having a look at the achievement standard where we can see years 3 and 4 and years 5 and 6 beside each other. So when you are assessing students, it could be helpful to think, have students translate an algorithm given as a flowchart of text into a visual program that can be run? And did the algorithm contain branching and iteration? Also sequence and input and variables for years 5 and 6. There's also the expectation for complex branching at years 5 and 6 as well. So as we demonstrated before, the chatbot activity, you can use the Grok platform as an assessment tool. So a lot of the courses finish with a playground at the end. And yeah, students can just see what blocks are there and have a task from you, and off they go and do all their coding in the playground. I've personally found it very handy because all the students code. So, you know, they've implemented all the algorithms. It's all in the one place. So you can assign students a course and then just say, put all your code in the playground in that course. And that's really handy. When you go to the teacher dashboard, you can just see when you're thinking about assessment and you're making judgments based on evidence of student learning. Just having it all in the one place can be really helpful. Another thing you can do with when you're thinking about assessment is a code review. So sometimes solutions can be shared between students, and it might look like they understand the program, but just to make sure, it is can be time consuming, but just having conversations with students. For example, you could sit down beside a student and say, you know, could you point out the 3 control structures? Can you actually highlight them in your program and talk about them and tell me what they're doing? I've noticed with robotics, you tend to get students, when they're working in teams, you get the builders and the coders, but the builders need equal opportunity to learn coding and progress with their coding as well, and vice versa. The coders need to do some building. And students can also review like their own programs when they're writing comments about their programs and demonstrating their understanding. They're doing the review themselves, and if I've got comments that explain each part of their program, it means if someone else was to take their program and modify it or use it and put it in a different context, very quickly they can see the big picture of what the program does and use that and apply it in a different context.
Another important part you could do for assessing coding is to have a rubric for students, what they've produced, the code that they've made. And on the right there is one of the other little kind of one of the little tasks that you can find on the Grok website. It is based on Australian Curriculum 8.4, but it does have sort of an example of assessing there. But let's have a think about some of these, how we would put these in a rubric. So, for example, the overall functionality. Does the program do what it's meant to do? Code readability. Maybe a below standard would be the code just isn't organized. The names of variables don't make sense. There isn't any commenting. That might be below standard. At standard, the code has basic organization and it has some comments. And above standard is the code is optimally organized. The variables have really suitable names and appropriate comments are there where they should be. The use of control structures, so sequencing, branching, iteration, have those things actually being used? They could all be part of your rubric as well. So for iteration, for example, below standard, they didn't use a loop at all. They just copied and pasted the code over and over instead of using a loop, perhaps. At standard, appropriate loops are used as necessary. And then above standard, the loops are used in conjunction with branching or inside other loops, showing a little bit a higher level of understanding there. And then another one would be the use of variables, of course, at years 5 and 6. And there are tools out there for generating rubrics. The Victorian Curriculum and Assessment Authority, VCAR, has some guides there for doing formative assessment rubrics, but there's also there's the solo taxonomy, and that's where that Pam Hook website will take you to that can generate rubrics for that. But you obviously should be guided by your own school's approach to doing rubrics and grading assessment when you're trying to do one for coding products that students have made. One last thing we wanted to quickly talk about is student misconceptions about coding. Students may come to coding thinking that it's boring or it's a skill for people who are good at maths. And this is definitely not true, but it's good to vary the activities. You don't want your activities to be all maths based like the last example we gave, but you want ones that have lots of different things involved. You're a bad coder if you can't write everything for yourself. Of course, in the real world, coders do grab bits and pieces of code from all over the place to use. The idea that being a coder is antisocial, and if you actually look at coding jobs in companies, there's so much collaboration now and so much working together. The idea that coding isn't creative, like it is a kind of creativity of all of its own. Coding is about completing tasks but not communicating. And once again, to do well in coding, it's important to also be able to communicate well. And then coding isn't relevant to your career plans. Well, these skills are very much useful in all areas of life, I think. So yeah, these are definitely misconceptions that we can talk about.
Cool. So if we've just got some resources there for further reading. So there's some programming pedagogy articles just talking about that generally, or if you wanted to zero in on specific pedagogies, you could look up those articles on Prim or the Parsons problems. Looking ahead, there are more sessions to come, so 5, 6, and 7, privacy and security, data collection and analysis for secondary, or digital literacy for primary. And then there's designing and assessing digital technologies projects. So if you wanted to get in contact with us, here's our contact information. So there's a website and email address as well. We thank you for listening to Algorithms Part 2, and good luck with implementing those algorithms with your students.
Thanks, everyone.
Thank you.